Namaste students. Today we are going to start with the differentiation of parametric functions. Differentiation of parametric functions. Now what are these parametric functions? Sometimes, like whatever the questions we were doing it right now, it was a relation between y and x. Whether it was an explicit relation or it was an implicit relation. Alright, y was expressed in terms of x or it was a mixture of x and y. But sometimes what happens? X is a function of some other variable. They are related to the third variable. X is a function of t and y is also a function of t. X and y do not have a direct link with each other. They are the functions of some third variable, and this variable is called parameter. This is called parameter. That's why this form is called parametric functions. X is a function of t, y is a function of t. What do we need to find out? We need to find out dy upon dx. See, as such, y is not directly related with x, but I have to find the differentiation of y with respect to x. So how do we find it? Y is related to t, so I will differentiate y with respect to t. X is related to t, I will differentiate x related to t. When I will divide it, I will get the value of dy upon dx. So very easy. What do you need to do? X is a function of whatever variable, y is a function of whatever variable. I need to find out dy upon dx. Differentiate x with respect to this variable, differentiate y with respect to this variable. To find dy upon dx, divide dy upon dt with dx upon dt. So we'll get the differentiation of parametric functions. Alright, clear? Clear to everyone? Now, let's pick up a question. Very easy concept. For example, I have x is 80 square and y is 280. We need to find dy upon dx. We need to find dy upon dx. Alright. So here x is related with t. A will remain a constant. So I differentiate x with respect to t, dx upon dt. A is a coefficient. Differentiation of 2t, t square will be 2t. Differentiation of x with respect to t, so t ka differentiation with respect to t will be 2t. Then I will differentiate y with respect to t. 2a is a coefficient, will remain as it is. T ki differentiation with respect to t only will be 1. That's it. I need to find out dy upon dx. So that will be dy upon dt upon dx upon dt. Put the values. Clear? So 1 by t is the answer. Alright children, I hope it's clear to everyone. Let's pick up one more example. Say x is cos theta plus cos 2 theta. And y is sin theta plus sin 2 theta. We need to find out dy upon dx. So first of all, I'll find x with respect to theta, because x and theta has a direct relation. Differentiation of cos theta will be minus sin theta. Differentiation of cos 2 theta will be minus sin 2 theta. Into differentiation of 2 theta, that will be 2. Alright. Now differentiation of y with respect to theta. Differentiation of sin with respect to theta will be cos theta. Differentiation of sin 2 theta will be cos 2 theta. Into 2. Differentiation of 2 theta will be 2. Alright, clear? Now simple, I need to find out dy upon dx. So it's going to be cos theta plus 2 cos 2 theta upon sin theta minus 2 sin 2 theta. Minus 2 sin 2 theta. Is this clear? Alright, that was minus with both. So this is minus, so I want to take negative common, so I can take negative out, so minus will remain outside. It will be sin theta plus 2 sin 2 theta. I hope it's very clear to everyone. Simple, you will differentiate the first variable with respect to the variable it is directly linked with. Second variable we will differentiate and then divide both to get the required answer. Let's see the next example. Example 3. X is a function of t, y is a function of t. I need to find out dy upon dx. So I'll differentiate dx upon dt. I told you basic operations of differentiation will not change. If it is two functions, I have to apply u into v. First function as it is, differentiation of cos will be minus sin t. Cos t as it is, differentiation of et will be et. Et common, inside I have cos t minus sin t. It's a systematically you need to write. Alright, now I'll differentiate. Here only I can differentiate dy upon dt. First function as it is, differentiation of sin t will be cos t plus sin t as it is. Differentiation of et will be et. Et common, cos t plus sin t. Divide. So dy upon dt upon dx upon dt. Cancel. Alright. So the answer is cos t plus sin t upon cos t minus sin t. If you want to apply some formula, say sin c plus sin d, you can. Otherwise, as such not required. So this will be my answer, cos t plus sin t upon cos t minus sin t. Now looking at the next one, I'll find out dx upon dt from here. See, do not be scared by length of the question. It's very easy, simple differentiation. Differentiation of cos t would be minus sin t. First of all, here the differentiation of log. What is the differentiation of log? 1 upon x. So 1 upon t by 2. Is it clear? Fine. Into differentiation of tan. What is the differentiation of tan? Secant square t by 2. Into the differentiation of t by 2. What will be the differentiation of t by 2? 1 by 2. So we have, I can write this secant square as 1 by cos square and tan t by 2 as sin by cos. So what will happen if I write this secant square 1 by cos, sin by cos, cos and cos cancel, 1 cos left. So what I'll get in the denominator? 2 sin t by 2 cos t by 2. See, you have to simplify it also. It's not like differentiation to khatam ho gaya, differentiation is over. That doesn't mean differentiation is over, you leave the question there and then. You have to simplify maximum it is possible. Alright. So now I hope you remember what is the formula. 2 sin x cos x. That is the formula of sin 2x. Doubles formula of sin 2 sin x cos x. Sin 2x, the angle gets double. T by 2 का क्या बन जाएगा? T. Take LCM inside the bracket. What is 1 minus sin square? 1 minus sin square is cos square. And we have sin t. Let it be for time being like this. You can write it as cos upon sin cot and 1 by sin cosecant. But let's see the differentiation of y first. dy upon dt. A as it is, differentiation of sin will be cos t. I need to find out dy upon dx. So I divide dy upon dt by dx upon dt. One cos cancel, a and a cancel, sin will go up, cos is below. I have tan t dy upon dx, but now they are asking me to find dy upon dx when t is pi by 4. So at t pi by 4, put the value of pi t as pi by 4, tan pi by 4 is 1. So this is how we are going to do it. I hope it's clear to everyone. Separately differentiate x and y. Then whatever is asked, if they have asked you dy upon dx, divide dy upon dt by dx upon dt. If they ask you dx upon dy, so dx upon dt will be divided by dy upon dt. I hope it's clear. Let's see the next one. X is equals to cos inverse 1 by under root 1 plus t square. Y is equals to sin inverse t upon under root 1 plus t square. I need to prove that dy upon dx is equals to 1. Now, I hope you remember the differentiation of inverse trigonometric functions. I told you when you have cos inverse or any inverse trigonometric function, first of all you try to simplify it, because if I talk about the formula of cos inverse, differentiation of cos inverse, it is minus 1 upon under root 1 minus x square. If you take this complete as x, the calculation may be a little bigger. So better you substitute something, bring it to the smaller one and then differentiate. And I hope you remember the substitution rules which we did in inverse trigonometric function chapter. So when I have 1 plus t square, I'll put t as tan theta. It is just for simplification. Differentiation we'll do later. So it has become cos inverse 1 plus t square is secant square. Secant square under root will be secant theta. And 1 by secant is cos theta. Simplification purpose is this only. बाहर जो भी inverse trigonometric function है अंदर वो same बनाना, so that by rule they get cancelled and it is theta. Put the value of theta. What will be the value of theta? Tan inverse t. Now say it's single function. Now differentiate. Dx upon dt will be, what is the differentiation of tan square? Tan inverse t, 1 plus 1 upon 1 plus t square. I hope everyone remember differentiation of tan inverse x is 1 upon 1 plus x square. Same way I'll differentiate now this. Here also I have 1 plus t square. My substitution remains same. That put t is equals to this. So y tan theta upon under root 1 plus tan square theta. That becomes secant theta tan inverse, tan can be written as sine upon cos, secant can be written as 1 by cos and cos cancel from the denominator. So I am left with sine inverse sine theta, sine and sine gone, so theta, put the value of theta, that is tan inverse t. Differentiate with respect to t, dy upon dt will be 1 upon 1 plus t square. Now what is asked? Now asked dy upon dx. So therefore dy upon dx will be dy upon dt, that is 1 upon 1 plus t square, upon dx upon dt, that is also 1 upon 1 plus t square, cancel. So I got answer 1. Alright, very easy topic girls. Fine, so just differentiate the variables separately, the functions separately, and they divide according to the requirement. Let's pick up the last example. X is equals to under root a sine inverse t, y is equals to under root a cos inverse t. Prove that dy upon dx is minus y upon x. So under root means what part? First of all, let's convert this symbol into number. So when I differentiate, I told you, you can't forget chain rule. First of all, the differentiation of the power. How we differentiate power? Power comes in front, reduce the power by 1. So 1 by 2 minus 1, that will be minus 1 by 2. Alright. Into. Power का differentiation is over. अब क्या नजर आ रहा है अंदर? A sin inverse t. Which form is this? This is a raised to power x, which is a raised to power x into log a, whose differentiation is a raised to power x into log a. So it will be a sin inverse t into log a. Now differentiation of a is also over. What is differentiation of whose is left? Sin inverse t. What is the differentiation of sin inverse t? Under root 1 minus t square. Alright, sin inverse x is under root 1 minus x square. 1 upon under root 1 minus x square. Just arrange it systematically. We can do one thing. See, a raised to power sin inverse t raised to power minus 1 by 2. यहाँ पर है a sin inverse t की power 1. When the bases are same, powers can be added. So क्या बन जाएगा ये? A sin inverse t. This is the power minus 1 by 2. This is power 1. Minus 1 by 2 plus 1 would be 1 by 2. Rest log a here. In denominator we have 2 under root 1 minus t square. Whose value is this? A sin inverse t raised to power 1 by 2 means under root. What is that? X. So in place of this I can substitute x. Alright, similarly I am going to differentiate y dy upon dt. First of all, the differentiation of the power, reduce the power by 1. Then differentiation of a to the power x form, that remains a to the power x only, dy into log a. Then the differentiation of cos inverse t, that is minus 1 upon under root 1 minus t square. Same thing, when the bases are same, powers can be added, so it will be a cos inverse t to the power 1 by 2 log a, there's a negative sign, upon this. Fine. And whose value is this? This is equals to y. So dy upon dt is 2y log a, not 2 here, minus y log a upon 2. Clear, children? Now what do we need to find out? I need to find out dy upon dx. We need to find out dy upon dx. So dy upon dt, which is this, upon dx upon dt, which is this, cancel, that is my minus y upon x. Alright, I hope parametric functions are clear to everyone. Very easy concept. Parametric function means when x is a variable of t, y is a variable of t, means not exactly t, it can be any third variable. X and y to 2 variables हो गई, they are the function of third variable, and that the third variable is called parameter. That third variable is called parameter. So what do you have to do? You have to differentiate first function with respect to whatever the parameter is given, second function with respect to whatever the parameter is given, and then divide them to find the required differentiation. I hope the parametric functions are clear to everyone. Okay, now we are going to start with the next topic. Derivative of a function with respect to another function. See, this also becomes a kind of a parametric function. Alright, I have to derivate one function with respect to another function. I'll just give you an example. Let fx and gx be two functions of x. Okay, there are two functions of x, and then they asked me, then differentiate fx with respect to gx. They said differentiate fx with respect to gx. अब ये नहीं बोल रही कि fx को with respect to x differentiate करो, no. This is differentiate complete function fx with respect to gx. So what do you do in this function, in this kind of problem? Like for example, they say fx is sin x and gx is cos x. They said differentiate sin x with respect to cos x. They are not saying differentiate sin x with respect to x. Differentiate sin x with respect to cos x. So what do? We give the functions as different names. Say this is y and say this is z. Now speak like this. They are asking me to differentiate fx with respect to gx. So that means I will not fx and gx नाम नहीं बोलते, b वाले नाम बोलेंगे. They are asking me to differentiate y with respect to z. That means they are asking me to find dy upon dz. Very simple. This has also become a parametric function. They are asking me to differentiate y with respect to z because I have given the name to y and gx z. वो आसान रहता है बोलने के लिए ना, ऐसे तो करते आ रहे हैं. fx को gx के with respect to करो, better है y को with respect to z करो. So dy upon dz तो कैसे निकलेगा? y का रिलेशन x के साथ है तो क्या निकलेगा यहाँ से? dy upon dx. z का रिलेशन x के साथ है, यहाँ से क्या निकलेगा? dz upon dx. And then we will differentiate. Again a parametric form, but not a direct parametric form. They have given this parametric form indirectly when they ask differentiate one function with respect to other function. We'll pick a few examples, then it will be clear. Let's pick a few examples for the clarity of concept. Read the first one. Differentiate tan square x with respect to cos square x. So nothing, you don't have to be scared, just give them the names. Let tan square be y and cos x square be z. Tan square x with respect to cos square x or cos x square, whatever is given to me. So now, or whatever it can be, cos square say x. So here I differentiate y with respect to x. So differentiation rule remains same. Power का differentiation 2 tan x. Tan x की differentiation secant square x. That's it. Now I differentiate z with respect to x. पहले power का differentiation 2 cos x. Cos x की differentiation minus sin x. Now I need to find differentiation of y with respect to z because they're asking me to differentiate this with respect to this. So dy upon dz will be dy upon dx upon alright, whatever the cancellation is possible, we can cancel the terms and we can write the answer like this can be written as sin x upon cos x. This is 1 upon cos square x. This is cos only and into sine, no change. Sine and sine can be cancelled. So I have how many powers of cos? 1, 2, 3, 4. Cos raised to power 4. That means the answer is secant 4x. Is it clear to everyone? Alright. So just give them the names and differentiate one variable with respect. Let's see the next one. Differentiate x raised to power x with respect to x. So I'll name them separately first of all. I hope you remember this. This is variable raised to power variable. Logarithmic differentiation. So I'll take log on both the sides because I don't know how to differentiate this. So log m raised to power n. Now differentiate both sides with respect to x. 1 by y. Dy upon dx. First function as it is. Differentiation of log x is 1 by x. Log x as it is. Differentiation of x is 1. So dy upon dx, y will go that side and I will put the value of y. I told you in logarithmic differentiation, जहाँ से question start होता है, that comes in the answer. Then I'll differentiate now z with respect to x, u into v. First function as it is, differentiation of log x would be 1 by x. Log x as it is, differentiation of x would be 1. So 1 plus log x. What do I need to find? I need to differentiate y with respect to z. So that means I need to find out dy upon dz. So dy upon dx upon dz upon dx cancel. So I am left with x raised to power x. Very easy. No problem at all. Very easy topic. Once you know the differentiation, the basic rules of differentiation, everything is possible. Now look at the third one. Again I will name them. Y. This is z. I'll differentiate z first because that's a direct formula. dz upon dx, tan inverse differentiation is 1 upon 1 plus x square. Alright. Now this, again the same thing I told you in the previous topic also. Whenever you have inverse trigonometric function, if it is not direct, that was just a simple tan inverse x. So you have to substitute and check. So what I'll do? Now 1 minus x square, 1 plus x square. You know that there are two rules. One is the substitution rules which we have. If 1 minus x square is we put sine, cos, 1 plus x square we put tan, cot. Alright. But then other substitutions are by seeing the formula. I have to make cos outside, so I'll put inside, I'll put this because I hope you remember the formula of cos 2 theta in terms of tan. 1 minus tan square theta upon 1 plus tan square theta. That is the formula of cos 2 theta, cos gone. So I is equals to 2 theta, put the value of theta, that is tan inverse x. Alright, value of theta is tan inverse x. So dy upon dx, now differentiate, 2 is a coefficient, tan inverse differentiation would be 1 upon x square. Now what do I need to do? I need to find out dy upon dz because the question was differentiate this with respect to this. And the name of this was we gave y and that was z. So dy upon dz. So dy upon dx upon dz upon dx cancel. So my answer is 2. I hope children both the topics are clear to everyone. Parametric form, and this is differentiation of one variable with respect to, not one variable but one function with respect to other function. And this is also a form of parametric functions. I hope it's clear to everyone by now.